Material sorting automation is the process of using machines and software to classify and separate different types of materials according to their properties, such as size, shape, color, material, weight, etc. Material sorting automation can improve the efficiency, accuracy, and safety of various industrial and logistic applications, such as recycling, manufacturing, packaging, and quality control. Examples of material sorting automation are an automated sorting system that uses PLC and CADA to sort objects according to their materials, wood, metal, and plastic, by using different sensors and pneumatic cylinders. A lift automation system that uses PLC to sort objects of different sizes by using a vertical upward movement of a lift. An automatic material sorting machine that uses a microcontroller and a touch screen to sort objects according to their colors by using a color sensor. Material sorting automation is the process of using machines and software to classify and separate different types of materials according to their properties, such as size, shape, color, material, weight, etc. Material sorting automation can improve the efficiency, accuracy, and safety of various industrial and logistic applications, such as recycling, manufacturing, packaging, and quality control. Starting and stopping a conveyor system typically involves using a control panel or interface that is integrated with the conveyor system. Here are the general steps to start and stop a conveyor. Starting the conveyor. Ensure that the emergency stop buttons are released and the system is ready for operation. Activate the main power switch to supply power to the conveyor system. Check the control panel for a start button or switch. Press or switch on the start button to initiate the conveyor operation. Once the conveyor starts moving, ensure that the materials are loaded onto the conveyor belt properly. 2. Topping the conveyor. In case of an emergency or malfunction, press the emergency stop button to halt the conveyor operation immediately. To stop the conveyor under normal operating conditions, look for a stop button or switch on the control panel. Press or switch off the stop button to bring the conveyor to a halt. Ensure that all materials are cleared from the conveyor belt before stopping it to prevent any jamming or accidents. Always follow the specific instructions provided by the manufacturer for starting and stopping the conveyor system, as different systems may have slightly different procedures. Additionally, always prioritize safety when operating and maintaining conveyor systems.
Network 1 in this network. I am writing the logic for start the cycle and unloading conveyor logic. Input are start I0.0, stop I0.1, and emergency stop I0.3M. 0.3 is cycle on memory bit. Here is M. 0.0 is cycle start output bit. Q0.0 is start lamp feedback and Q0.1 is stop lamp output. Once cycle start conveyor 1 and 2 will run but condition of turntable front limit. Stop the roller conveyor 1 till the front limit sensor got in normal condition. After conveyor will run once material placed in right place. Same conveyor 3 and conveyor 4 run for continuous delivery of shorted material as per vision sensor inputs. Vision sensor will describe in next networks of logics.
Network 2. In this network, I am writing for emergency stop pressing by input I0.3 push button. Emergency stop shutdown to total operation by Q0.3 emergency lamp indication. Network 3. In this network, we get the cycle on bit energized condition to proceed next action of logics. Kindly note that here I am using value 1 bit M0.0, value 4 bit M0.1, and value 7 bit M0.2. These memory bit represent the vision sensor values for 3 color material. Value 1 is blue part material, value 4 is green part material, and value 7 is gray part material. All value defined on upcoming networks logics rungs. Interlock input I0.5 is turntable front limit. When all bit will healthy then conveyor 2 represent the run operation for material handling to next step. Network 4. This network is main part of this program. Vision sensor is analog device. It will generate different values for different 3 color materials, here Vi. Cyan sensor input IW30 sense the value for 1 number ID material. 1 ID number input value defined as blue part material is sensed by sensor and timer T1 activated for 15 seconds with off delay. Now output represented as value 1 memory bit. This bit used for operate the right material placements in right direction. Blue part placement at right conveyor defined as light indication output Q1.7. It will glow when material direction at defined conveyor. Network 5. This network is second step of this program. Vision sensor is analog device. It will generate different values for different 3 color materials, here this. Ion sensor input IW30 sense the value for 4 number ID material. 4 number ID input value defined as green part material is sensed by sensor and timer T2 activated for 15 seconds with off delay. Now output represented as value 4 memory bit. This bit used for operate the right material placements in right direction. Green part placement at right conveyor defined as light indication output Q1.6. It will glow when material direction at defined conveyor. Network 6. In this network, timer T6 on and activate the turntable. It will turn for 90-degree angle, and by getting I 0.7 to goes as high. Turntable 2-bit and turntable 2-bit used for green and gray material movements. Both bits will define the direction of green and gray color material. In this network, value 1 blue part material will activate and turn on the roller conveyor output Q0.1. It will main cause of place blue part material. Now value 4-bit get high and sensed by turn back limit the Q1.2 and start the front direction of conveyor. Latch bit M1.2 with the front limit table sensor move the material in 90-degree angle and AF. Ter of few second time hold the table conveyor will run. After front limit sensor it will return in home position for next operation. Same in this condition, forward operation started and reverse operation halted by M4.0. Next condition will work for reverse condition and hold forward movement. In this network, turntable run operation will control by M3.0 bit. When turntable bit 1 cubic meter point .0 get high signal, table will be ready for turntable operation. M3.3 reverse turn enable on, the timer T18 and ready for turn the table in reverse direction. Network 9. Value 4-bit generated by vision sensor. After sensing green part material, it will active the timer T4 activate the M0.6 with the 5-second delayed. Network defined by value 4-bit 5-second latching bit. It will used for how many time value 4 will used. It may cause of control the blue part material movement for n numbers of operations. Network 11. Kindly note we have more challenge to separate the reverse and forward table operation. We need to isolate the both color material in same real-time operation. Bit M1.1 and M1.2 will play the role in next rungs of logics. Network 12. This network is third step of this program. Vision sensor is analog device. It will generate different values for different 3 color materials. Here V Asian sensor input IW30 sends the value for 7-number ID material. 7-number ID input value defined as gray part material is sensed by sensor and timer T3 activated for 15 seconds with off delay. Now output represented as value 7 memory bit. This bit used for operate the right material placements in right direction. Gray part placement at right conveyor defined as light indication output Q1.5. It will glow when material direction at defined conveyor. Network 13. This network value 7 is defined for reverse status acknowledge bit M2.5. After getting this acknowledge the system, it is ready for sense to gray color material. Now turntable will be ready for operation. Network 14. Now this network getting M2.5 bit high condition by activation of timer T15 for 1 second. Turntable front limit activated and timer T19, it will activate for 3S and reverse table cycle will enable. Turntable on bit represented by M4.4, timer T20 will disable to reverse after 5-second time.
Swagger down the street with your red lips and funky beat. You better hold your head up to the sky. I'm gonna roll with you till the day I die.
Network 15. We used turntable on bit M4.4 in network 14. There is the main use of activation of this bit. M4.4 will activate the time T17 for 13 seconds and on the turn 2 roll output Q1.3. Same Q1.3 activate the table angle to 90 degree. On this condition we will finalize gray part material placement at right direction. Network 16. Now question is how many color part material sorted. So in this network we can count the blue part material by counter block. I1.0 retroreflective. Sensor sense the material and count the total sorted parts. We can reset the values by I0.2 by reset push button. QW30 is count value of blue parts in operations. Network 17. Now question is how many color part material sorted. So in this network we can count the blue part material by counter block. I1.1 retroreflective S. Sensor sense the material and count the total sorted parts. We can reset the values by I0.2 by reset push button. QW32 is count value of green parts in operations. Network 18. Now question is how many color part material sorted. So in this network we can count the blue part material by counter block. I1.2 retroreflective S. Sensor sense the material and count the total sorted parts. We can reset the values by I0.2 by reset push button. QW34 is count value of gray parts in operations.